Welcome back. In this lesson, we're going to be able to apply what we know about polynomial factors and zeros. I've got words with different colors here purposefully, so I'm going to ask you some questions in a moment. To successfully use the remainder theorem and the factor theorem to verify or check possible solutions. Okay, so I want to talk about some of these words that I have in a variety of colors. So number one. Tell me what you obviously can't tell me, but tell yourself, tell your brother, your sister, your mom, your dad, grandma, grandpa, whoever, someone, your friends, text your friend, about what do you know about factors and solutions, right? Or factors and zeros, right? Because these are asking two different things. And so I think it's really important that you're paying attention to what is being asked of you. What's the difference between these? Factors are like x plus 2, right? Or x squared plus 3x minus 5. This is a linear factor. This is a quadratic factor, right? Those are factors. I'm not actually seeing like what are my x-intercepts. It's in factored form. Whereas your zeros or your solutions are when you use the zero product property. And find actual x-intercepts. Your zeros will be your real solutions. Technically, your solutions can be imaginary, right? You can have imaginary solutions. So I might be asked to factor something, and I'm going to get f of x equals x plus 2 times, I'll go with what I did, x squared plus 3x minus 5. Whereas I might be asked to then solve it, and I'm going to go ahead and say x plus 2 equals 0, and so one of my solutions is negative 2. That's a solution, right? These factors. Oh, and then I can say x squared plus 3x minus 5 equals 0. If I can't factor this more, which I can't, I can use one of my other tools that I have. I can use the quadratic formula, negative b plus or minus the square root of b squared minus 4 times a times c all over 2a, negative 3 plus or minus the square root of 9 plus 20, 29, all over 2. Oh, now I've got my 3 solutions, right? 1, 2, 3. Okay? Now I've written a lot, right? So that's important. This, solutions, tell me about solutions on a graph, right? The real solutions are your x-intercepts. Okay? So keep that in mind. The remainder theorem and the factor theorem are new to us. They are not things that we have learned, but they are kind of extensions of what you've done with long division and polynomial division, right? So you can use long division, and synthetic division to determine if something is a zero, right? You can use them to help you to factor, okay? The remainder theorem and the factor theorem are going to help us together also be able to identify if something is truly a zero or if something is truly a factor, okay? So the remainder theorem is what we're going to start with. If f of x is a polynomial function, then x minus c is a factor of f of x, okay? If f of c equals 0. Right? Think about that for a minute. If I know, and really you knew this, like if I give you an equation, you know what? I'm going to go back to something real simple here. We'll go with a line. 2x minus 10, right? And you get x equals 5 is the solution, right? And what that means is when I plug in 5, I get out 0, right? That's a point on my graph. An x-intercept. That's why y is 0. So if I have x minus c as a factor, if I plug in c, right? Oh, check that out, x minus 5. In this case was a factor. I can factor out 2 and I get x minus 5. Whoa, you can still factor even though it's linear. Pretty crazy. If x minus c is a factor, then if I take c and I plug it in, I've used the zero product property to get c, I should get 0, just like I did up here in this example. And or the remainder when f of x is divided by x minus c is 0, right? And that we have the synthetic division and long division, that idea, okay? If you divide it by x minus c, you get a remainder of 0, right? Those are the things that would make x minus c a factor. Okay, so let's take this example of g of x, my function g of x. What is g of negative 3? If we plug in negative 3, sorry, I didn't need to make that pop up, but I already did. If we plug in negative 3, negative 3 to the 4th power minus 10 times negative 3 squared plus 9. Let's actually do this. What is this, 81, right? 9 minus 90 plus 9. Negative 9 plus 9 equals 0. Therefore, x plus 3 is a factor, right? Here, I just got g of negative 3 equals 0. So one of the points on this graph, if I were to graph g, is negative 3, 0. So x plus 3 is a factor, right? It's working in reverse. If I go ahead and I do long division, which I don't want to forget about, okay, well, this goes in here, what, x to the 3rd. So I've got x to the 4th plus 3x to the 3rd, subtract negative 3x to the 3rd, and bring down that negative 10x squared. Right, be careful, I'm missing a 0x to the 3rd in there, so don't forget that that's there. What is this? Minus 3x squared. Okay, so that's going to give me negative 3x to the 3rd plus, minus, 9x squared. Those go away. If I subtract, I get negative x squared plus 9. And this is going to go in negative x times. So that will give me negative x squared minus 3x. Oh, I was also missing, so this should be a 0x, sorry. When I subtract, it goes away, and I get 3x. That's going to go in 3 times, which will give me, and I have a 9 there. Bring down the 9. I forgot there was also missing a 0x in there. So you got 3x plus 9, subtract, oh, my remainder is 0. So really, you've been doing this. This is just slapping a name on something you know, is really what's happening here. Okay? Therefore, again, x plus 3 is a factor, and x equals negative 3 is a solution. Is x minus c a factor or not? Is c a 0 or not? So for instance, in this one right here, x plus 1, is x plus 1 a factor of this? Let's go ahead and use the remainder theorem. All we're doing here is plugging it in. I'm just finding what is g of negative 1. It is 0, therefore x plus 1 is a factor. By the remainder theorem, x plus 1 is a factor of g of x. Is 3 a 0? Sorry, push too much. Of, darn, where'd my equation go? I guess it's down here, right? So it's this, it's h of x, sorry guys. H of 3, negative 2 times 3 to the 3rd, plus 2 times 3 squared, plus 7 times 3 minus 10. Let's see, what is that? 3 to the 3rd is 27, so negative 54 plus 18 plus 21 minus 10, right? So let's see. 18 and 21 gives me 39. So I'm really doing negative 54 plus 39 plus 21. So negative 54 plus 39 is negative 15, and we already know this isn't going to work, right? Negative 15 plus 21 gives me 6. There's a remainder. The remainder is actually 6. Therefore, it's not, right? I know by the remainder theorem that it's not. If I want to verify it or justify it using long division, I would need to divide by x minus 3 to show that that doesn't work. Okay? So a corollary to the remainder theorem is the factor theorem. If f of x is a polynomial function, then f of b is equal to the remainder. Right, so this follows from it. I was kind of just saying this, right? In the last one we saw that we got a value other than 0. That's a point on your graph, right? Like you've been substituting in and finding points on graphs like for so long. F of b is equal to the remainder when f of x is divided by x minus b. Right, so here I've got h of x. H of 3 gives me negative 25. Therefore, your remainder is also negative 25, right? Like I could sit here and actually do the long division, right? And I would have negative 2x squared. Negative 2x to the third plus 6x squared goes away. Negative 4x squared plus 0x. What is that? So negative 4x. Negative 4x squared plus 12x. Negative 12x plus 7. Minus 12x. Nope, just minus 12. And then you've got minus 12x plus 36. Oh, this is weird. That was probably supposed to be an x. Oh, so I guess this was supposed to be an x. Another typo. I'll back up then. So this should have been a 7. 7. So 7, that's what? Negative 5x. So then this would be minus 5. And then you'd have minus 5x plus 15. Yep, that makes more sense. Then you get negative 25 as that remainder. So I dropped an x. Right? So actually, if we were to graph h of x, you certainly have the point, like that remainder is going to tell you a point that's on the graph. I have the point 3, negative 25 if I were to graph this. That's a point on this polynomial. It's not a 0. It's not an x-intercept. Okay. Right, so you can see that that point is on there. Right, so this is what the factor theorem does. Like that remainder that you're getting is the outcome, is the y value of that point. Okay, so not a crazy long lesson. This isn't anything really. I mean, you've realistically been doing this. You just didn't have a name for it, right? So I'll be able to apply what I know about polynomial factors and zeros. So just make sure you're paying attention to the difference between those to successfully use both the remainder theorem and the factor theorem. Okay, to verify or check for possible solutions. So this kind of builds on or goes along with, I didn't do any synthetic division in this, but long division and synthetic division to verify and find factors, right? So you can just plug in. So make sure that you are finishing off your Delta Math assignment this weekend and getting some practice with all of these skills. And we will see you soon in class. Thanks, everyone. If I can figure out how to